Welcome back, Stargazers, and welcome to the first episode of our series where we dive into the fascinating and often surprising facts about our solar system. Today, we're diving into the incredible world of the Sun. From its immense size and mass to its mysterious atmosphere, the Sun is a source of endless fascination. Buckle up as we explore some truly mind-blowing facts about our star. Let's get started. The Sun is a colossal entity, containing about 99.86% of the total mass of our solar system. Its diameter is so vast that you could fit approximately 1.3 million Earths inside it. To give you a sense of scale, the Sun's mass is around 333,000 times that of Earth. This immense mass generates a gravity 28 times stronger than what we experience on Earth. If you weighed 70 kilograms on Earth, you'd weigh a staggering 2 tons on the Sun, although you can't actually stand on it due to its gaseous nature. The Sun's composition is primarily hydrogen, making up about 74% of its mass, with helium accounting for roughly 24%. The remaining 2% consists of heavier elements like oxygen, carbon, neon, and iron. This mix of elements fuels the nuclear fusion reactions in the Sun's core, where hydrogen atoms fuse to form helium, releasing a tremendous amount of energy in the process. When it comes to temperature, the Sun is incredibly hot. The surface, or photosphere, has a temperature of about 5,500 degrees Celsius or 9,932 degrees Fahrenheit. But the temperature soars in the Sun's core, reaching approximately 15 million degrees Celsius or 27 million degrees Fahrenheit. This extreme heat is essential for the nuclear fusion that powers our star. The Sun constantly emits a stream of charged particles known as the solar wind. This solar wind extends well beyond Pluto's orbit and creates a protective bubble around the solar system called the heliosphere. The solar wind can interact with planetary atmospheres and magnetic fields, creating stunning auroras and occasionally affecting technology on Earth. The Sun's energy output is staggering, with around 386 billion megawatts of power radiating into space every second. That's enough to power 20 trillion Earths. This energy is a result of the nuclear fusion happening in the Sun's core, where hydrogen atoms combine to form helium, releasing vast amounts of energy. The Sun's magnetic field is 2 times stronger than Earth's and much larger, extending well beyond the orbit of Neptune. It drives solar activity, including sunspots, solar flares, and coronal mass ejections. The magnetic field undergoes a reversal approximately every 11 years, flipping the Sun's magnetic north and south poles, a process that influences the solar cycle and space weather. The Sun's atmosphere consists of 3 main layers: the photosphere, chromosphere, and corona. The photosphere is the visible surface layer. The chromosphere is seen as a reddish glow during solar eclipses, and the corona is the outermost layer, extending millions of kilometers into space. Despite being farther from the core, the corona is much hotter than the photosphere, reaching temperatures of 2 million degrees Celsius. This is known as the coronal heating problem, and scientists are still working to understand why the corona is so much hotter than the Sun's surface. Solar activity includes phenomena like solar flares and sunspots. Solar flares are sudden bursts of energy caused by the release of magnetic energy, while sunspots are cooler, darker areas on the Sun's surface caused by magnetic activity. Sunspots follow an 11-year cycle, with their numbers increasing and decreasing over time. One of the most significant solar storms on record is the Carrington event of 1859. This massive solar storm caused spectacular auroras and disrupted telegraph systems across the globe. If a similar event occurred today, it could severely impact our modern technology and power grids. The Sun rotates on its axis, but because it's a gaseous body, different parts rotate at different speeds. The equator completes a rotation roughly every 25 days, while the poles take about 35 days. This differential rotation contributes to the Sun's complex magnetic field and solar activity. Our Sun is approximately 4.6 billion years old and is currently in its middle age as a G-type main sequence star, also known as a yellow dwarf. It has enough nuclear fuel to last for another 5 billion years. Eventually, the Sun will expand into a red giant, engulfing the inner planets before shedding its outer layers and becoming a white dwarf. Finally, light from the Sun takes about 8 minutes and 20 seconds to reach Earth. This means that when we observe the Sun, we're actually seeing it as it was over 8 minutes ago. It's a fascinating reminder of the immense distance that light travels to bring us the warmth and light we rely on every day. In our exploration of the Sun, we've uncovered its massive size and mass, its fiery temperatures, and its complex magnetic field. From solar wind and energy output to sunspots and solar storms, the Sun is a dynamic and powerful force in our solar system. Thanks for watching. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to our channel for more fascinating content. Until next time, keep looking up at the wonders above, stargazers.